So what is a computer? This is a basic level technology class, and we're going to want to know what a computer is kind of at a baseline understanding. We don't need to know like how a processor works like in the fine details. I don't even know. I took a computer organization class, but even we didn't go into like anything more detailed than like what some of the basic components are. You know, I know what a logic gate is, but there's like a gap between, okay, what is a transistor, and then like how does it display graphics? Like I don't know anything in between there. This is kind of,
you did.
You know, this is this huge gap because I'm not a computer engineer. If I'm trained in anything, it's software engineering. So we'll look at some basic vocabulary. We got a computer. What is hardware? What is a CPU? What is memory? What is software? What is an application? Input-output devices. And then a really, really important one is the word interface, which we'll come to in just a second. So a few questions. What are the main components of a computer? What is an interface? What's the difference between hardware and software? We've got the main layers of a computer system. Who is John von Neumann and why the heck is he important? And then what is an input-output device? So I think we can do this in like 10 minutes to do the basic quick rundown on this. So the hardware is the bare metal of a computer. This is the physical components that make a computer what it is. It's all of the stuff that sits in front of you on the table. That's hardware. So all of that collected together falls under the broad umbrella of hardware. Software is the code that runs on the computer. It's kind of falls into the two main categories. Operating system, which is this big program that kind of governs everything that happens on your computer. And we'll talk about the operating systems in some detail later on in the course, but for the most part, you're probably running either Windows, Mac OS, or Chrome OS for this class. Any one of those three will be sufficient. And in fact, I advise you, if you have a phone, you can do the Zoom on a phone with as like a second screen, and then have your laptop or whatever in front of you. It's not a bad way to arrange things at your workstation. So we have operating systems and applications. So an application is usually, we say app. It's been shortened to app for a long time now. An application is some program that I run on my computer, like Microsoft Office, a web browser, Microsoft Word, stuff like that. We have this layered model of a computer. So at the very top, and I don't know why I couldn't get PowerPoint to make this like vertical. It had to do it horizontally. I wanted to look cool, but so the user is the main layer. That's you. That's you're part of the system. Otherwise, the computer is useless without a user. Then there's the application layer. Then there's the operating system that the application interfaces with, and then the operating system interfaces with the hardware. So each of these little areas here is what we would think of as an interface. It's a place where two systems meet and interact. And this is a really important concept in computer science, is everything interfaces with everything else. And you don't necessarily want the application layer to touch the hardware layer. And you really don't want the user to mess with the hardware layer. You don't want to be doing stuff with the hardware while it's running, because you'll be electrocuted. That's like, especially like the power supply, that's like 450 watts or more of electricity that could zap you good. The capacitors in there are like 3 inches long. They're huge. Well, on a desktop, not on a laptop. Those are much more low-powered devices. The technology that goes into making laptops and mobile devices is insane. Miniaturization of that stuff. So we'll get back to this concept here in a little while. Is this it? This is not the right slideshow, man. Something's missing. This is like the last slide, and I know I had more. What the heck? What do I have posted on the module?
It was really short when I went through it.
Same.
Oh my gosh, I'm missing some slides. All right, I will have to. All
I
right.
thought I was like supposed to research the information or something.
No,
I don't
no,
understand.
no, I was gonna go through it. I am so embarrassed. Okay. Um, all right. Well, here, let me bring up this. Uh, so this dude by the name of John von Neumann came up with this concept of what a computer should look like. Oh, this one. I'm going to open. Yeah. It should take me to Wikipedia. Wikipedia. Where's that picture?
Those were all in like the links at the bottom. You could click on them and it would bring you to all of that.
Bring me to this. Did you guys like look at it? This is the thing though. This is what I'm talking about right here. Is this? Let me switch which thingamajigger here. I'm going to switch which monitor this is pointing to. Okay. And then I'm going to, in Zoom, I can actually annotate things. Okay, so this right here is the computer. This part of it right here, what John von Neumann said is this is the concept that we should have of what a computer is. It should really consist of only two things. The control, the central processing unit, the CPU. It's usually like, in your phone, it's about the size of a dime. In a larger computer, it's like 1.5 inches square. It's just a little piece of silicon with a billion freaking transistors on it. That's the CPU. And then the memory unit. So the memory unit is this component in your computer that says, it's kind of like, it's sort of like what you're thinking about right now. If you put it in like brain terms, it's what you're thinking about and what you're working on at this exact moment. And so these two things are constantly talking to each other to get this job done. This line of communication, this interface right here is always busy. There's always the central processing unit, the CPU, is asking the memory unit for the next thing to do, and then it gets transmitted over, and then it executes that instruction, and then like sends some output to the memory unit again. And so this is happening billions of times every second. Is this like information exchange between these two things. Everything else, every other component on your computer, your screen, your keyboard, your mouse, your printer, your hard drive, those are all considered input devices or output devices, or it just keeps on writing. Input device and output device. Those are not part of the core architecture of the computer. Those are all peripheral to the running of the computer. So the computer says, hey, I want to find an operating system. The only thing that it knows how to do is load that operating system into memory. And once that is in there, the memory unit is what like contains the operating system. So that's everything that's going on the computer is right here. And when it wants to load a program, it goes to the hard drive. And then that gets loaded into here. And then it can run that program. You can run your word processor or whatever. Let's clear this out here. Annotate. Clear. Okay. So that's kind of like the basic idea of the architecture of a computer. I'll probably add to this slideshow here, but we're already at half an hour, and I don't necessarily want to push us all the way to. I don't want these talks to go on for too terribly long in general. So I'm going to add a little bit to the slideshow, and we'll come back to it on Monday. But I think that despite the fact that I somehow totally lost the other copy of this file, even though it's like on Google Docs, like I didn't, there's no reason for me to have lost it. I have no idea where the rest of the slideshow went. See, this happens to everybody. So, this is perfectly normal. Let me go back to the questions in the slides. So we have, so John von Neumann is the guy who came up with this architecture, and we'll talk a little bit about some other key historical figures in this whole thing. But for the most part, he's the guy that came up with the design philosophy of a modern computer. So yeah, I/O devices. These are the things that we connect to a computer to make it do stuff that's useful. because a CPU and a RAM is missing one really critical component, a way to interact with it by you, and a way to get anything out of it. It doesn't have a screen. So we have to create interfaces between that device, this central core concept of a computer, and you in the outside world. So a car has a lot of computers that have like little sensors and things. Like there's an O2 sensor in the engine to make sure that the fuel mix is okay. You know, there's temperature sensors to make sure that it knows when to run the radiator. So a computer has ways of interacting with the outside world. This one in front of me has a camera. It has a keyboard. So it senses me pushing keys when I tap on the keys or move the mouse or play with this drawing tablet to do, to give it input, and then it responds to that. So if I draw a circle, it gets drawn on the screen. That's about that. Oh, whoops. Annotate, clear all my drawings. Okay, so I'm going to stop the recording now. This is kind of a high-level look at what a computer is.